Okay, I'm going to explain how the Z transform works, or the Z values, pardon me, for the normal distribution, because I think this is going to be a question on the test. So what I'm going to do is I'm going to draw my normal distribution curve one underneath the other so that you can see how they are related. And the main thing that we want to look for when they're asking us about this is if they ask you to find the standard deviation or the mean, this is going to need you to use this formula. Z is equal to x minus mean over the standard deviation, which is in your formula booklet. And your goal is to find a z value and an x value so that you have two unknowns. And then what you're going to do is find a second equation with the exact same idea, but instead I'm going to call this z2 and x2, while I call this one z1 and x1. So that's your goal. You're going to try and make two equations and two unknowns. If only the sigma is missing, then you only have to make one equation with one unknown. So let's take a look at this and see how it's done. I'm going to draw a normal distribution curve like so, and then I'm going to cut it up, and I'm going to make an exact copy of this thing. So copy, paste, bring it down there, put them on top of each other. Okay, and then from here, the top one is going to be my ones with my x values here, and my bottom one is going to be with my z values here. So this is the z value one here, and then this here is my x value. So in this case, my x values are the weight of an avocado. And here they tell us that the maximum weight of a small avocado is 106.2 grams. So it's the maximum weight of a small. And according to this, a small takes up 0.04%. And what I'm going to do is I'm going to draw the exact same amount here, and that's going to be 0.04. Now, the x value that gives me that is 106.2. And there's going to be a z value that gives me the exact same thing. I'm going to call it z1, but I don't know what it is yet, right? Then I'm going to do the same thing with the next piece. So the minimum weight of a premium is 182. So that means the minimum weight is going to be anything from 182.6 forward. So this is 0.096. Okay. And what I'm going to do is I'm going to draw the exact same amount on my standard normal distribution curve. So this one is the standard. Remember, these are all my z values. And I know that my mean is 0 on my standard normal distribution curve, and my standard deviation is 1. And of course, on this curve here, there is going to be a mean and a standard deviation, but we don't know what that is yet. Okay, so I'm going to call this x1, I'm going to call this x2, and we have z1, and here this is going to be my z2. And now what I can do is I can start creating my formulas here. So my z1, I don't know it yet. I'm going to show you how to find that in a moment. My x1 is 106.2. Subtract my mean over my standard deviation. And I'm going to have my z2 underneath that. And of course, my x value that goes with my z2 is 182.6 minus the same mean over the standard deviation. Okay. Now I need to find these z1 and z2 values, and it's quite simple. We're going to take out our calculator, and what we're going to do is use our distribution section. So second distribution, and these here along here, anytime you're trying to find the data value along one of these lines here in your normal distribution curves, that's called the k value. And we have to use the command inverse norm. So I know I'm going to use that command. So you come here and you take inverse norm, and my area is going to be 0.04, We already know the mean for this is 0 and the standard deviation 1, so that's perfect. And when I paste that, I'm going to get a value of negative 1.75 with all the digits here. That means I know that this here, red, that's negative 1.75 dot 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 dot. So make sure you put your long value here. And now my second one, I'm going to have to do this again, but there's only one difference, and that's this calculator program is old, and the new calculator programs say left, center, right. So if you have the new TI-84, you can choose right, and you have to find the area from the right side here up to Z2. But because my calculator doesn't have that, I have to go 100% of this, subtract the amount here, which is 0.096. So what that's going to do is it's going to fill in this area all the way up to the Z value, and it's going to output it. If I do that, I have 1.304. So here is going to be 1.304. So now I have my two equations, my two unknowns, and you can use whatever way you want in order to solve this. I think it's easiest if you move the sigma in Z1, so you have sigma is equal to 106.2 minus mu all over negative 1.75 dot dot dot, and then I do the same thing here, move these, so I have another sigma is equal to 182.6 minus mu divided by 1.34. And because these two values are the same here, I can just make this one equal this one. So I would take this formula here, equate it to this one here, this equation here. And once you have that, the easiest way to solve the equation is plotting y1, plotting y2, and then finding the intersect. And that's going to give you your mean. And once you have your mean, of course, it's very easy to find your standard deviation because you just insert it here and that will give you your standard deviation. So that's how you do Z values. Find your X value and your X value, link it to your Z and your Z, use your equations, two equations, two unknowns, and you're good to get the simple 5 points in a question like that.